yet another kind of force that we have is bearing stress, or another kind of stress we have is bearing stress. So let's make our trusty cylinder again. And we're going to put this on some sort of fixed surface. So our fixed surface. And we're going to actually declare our area down here. This is our area of interest. And there's some force P pushing this cylinder into our surface, right? Well, there's going to be a stress associated with the contact of this cylinder with this surface. And that's what we call bearing stress. So our bearing stress is going to be, let's see if y'all can guess it. I'll give you 2 seconds. It's going to be P over A. It's always some sort of force over some sort of area. But this is associated with contact. So, it's whatever force. It's whatever force is being applied over a contact area. That's the best definition for it. Also, it's important to note that bearing stress is assumed to be negative because it's always compressive. You can't have like a tensile contact. Like if something's coming in contact with something else, like this, it's always compressive. You're always applying a compressive force. I can't pull this way and at the same time be in contact with this surface. That just doesn't make sense. So bearing stress always assumed to be negative. So what happens with bearing stress if we have like a bolted connection like this? We want to see the bearing stress of this pen against whatever support surface this is. So let's cut this support surface so that we can look at what we're dealing with. So we'll make a cut there, and then this is basically what we're looking at on the inside, right? Something like that. So the area that it's being applied over is it's less intuitive than you think, because this is rounded. So where does the contact stop? It's not going to be equally distributed. So this is actually a more complex problem than you think. So what us engineers do to simplify it is we use what's called the projected area. So you see this hole here. Instead of trying to figure out complex things with the area of the actual like side of the hole, things like that, we're just going to take the area here, like basically in that plane. So if we were to make like a front view of this, so if this is our cut, and this is the hole right here, so hole, and those are the actual like supports themselves, we're looking at this area right here, and we're quite literally just taking the diameter of the hole and multiplying it by the height. And that simplifies our problems a lot more. So now we have our area, we have our P, bearing stress is P over A. So that makes our problem a lot easier than it would have been otherwise. So that's why we take the projected area in those situations. I hope this made sense. If it did, make sure you subscribe, make sure you like, tell me in the comments, and I'll catch you in the next one.